Welcome back. So in this lesson we will talk about two things. First we will talk about multi-class SVM, and then we will talk about how we can use SVM for regression tasks, right? So let's start with the first thing. So here we have multi-class SVM. So throughout our discussions for SVMs and how SVMs works and all this, we saw that SVM is actually a binary classifier. So all the problem formulation, all the mathematics, all the concepts are based on using two classes or having two classes, right? But in case we have multi-class problems, like the iris dataset for example, we have three classes. So we want to have a decision boundary for the three classes, right? So we know that SVM only considers two classes. So if we have an M class classification problem, so M can be 3, 4, 5, 6, whatever, then we will have M SVM classifiers. Okay, so the first SVM, SVM1, will learn output equal 1 versus output not equal 1. So the decision boundary we will get for the first SVM classifier will be two classes. The first class is 1 and the second class is not 1, right? So 1 versus not 1. And then the second SVM classifier will be 2 versus not 2. So the decision boundary we have for this classifier will be 2 versus not 2, and so on and so forth. So the M classifier, right, classifier number n, will be output equal M versus output not equal M. Okay, now in order to make a prediction, we have built our decision boundaries, right? We will combine all these decision boundaries together to have a global decision boundary, right? A decision boundary that we can use for any class. Now in order to make a prediction, to predict the output for a new input in the test data, just predict with each SVM and find out which one puts the prediction the furthest into the positive region, right? So we will check the first SVM, the second SVM, the third SVM, and so on, and we will see which one is putting this specific example the furthest into the positive region. So the one that will do this will be our classifier. So if we have 1, 2, 3, 4 for example, and we found that in the positive region for 1 we have something like this, and then for 2 we have something like this, for 3 something like this, for 4 something like this, then it will be classified as 4, right? Because it's the furthest away from the positive region. So this is how the multi-class SVM works. It's very, very simple, very straightforward, but if you don't know how it works, then you might be confused. So this is the multi-class SVM. Now, how we can use SVM for regression? Because throughout our discussions, we have been discussing SVM for classification, and we didn't really say how we can use SVM for regression tasks, right? Now, in order to do so, the trick is very, very simple. If you remember, the objective was in the classification tasks to maximize the margin, right? We wanted to maximize the margin. Now, for regression, the opposite is true. So we want to reverse the objective of the SVM. And instead of trying to fit the largest possible margin between two classes while limiting margin violations, what we are going to do for SVM regression is that we want to have line like this, right? We want to fit this line, right? So in order to do so, we want to fit as many instances as possible on the street, right? This is the street, the margin, while limiting margin violations, right? So the margin violations in this case will be instances of the street. So we have the same margin here, right? This dashed line and this dashed line, right? And this line in between, right? This is our line. What we want to do is that we want to fit as many instances as possible, right? And at the same time, we want to limit the margin violations, okay? But limiting the margin violations here means instances of the street, right? Instances outside the region, outside the margin. So in the classification, we wanted everything to be in this side, right? We don't want anything here, right? In case of hard margin, and in case of soft margin, we will have a penalty for anything in this region or anything in this region, right? Now for the regression, the opposite is true. Anything here is what we want, and anything in this region or in this region will be penalized. Okay, so it's just a matter of reversing the objective, and that's it. We have SVM working for regression tasks, right? So in the next lesson, we will discuss our project, and this project will be very, very unique and different from the other projects because we are going to work with Kaggle first, and for the dataset that we are going to use from Kaggle, we have a dataset for speech analysis. So we want to classify if the features we get from the voice, is it for a male or for a female? Okay, so let's go to the next lesson and see all this.